And we are live. Hi there, everybody, and welcome this Friday, 6th of January. We did it. We did it. Today, we have the weekly content launch for the week 6. Hey, Prokar, welcome. How's it going? We have Nika already here. And I'm going to take the next 5 minutes to send all the messages while Cody joins me on stage. And today, we also have Dan. Al is flying. Hey, Cody, do you want to jump on stage?
Hey,
How's
Happy
it
New
going?
Year.
Happy New Year. How are you?
Doing well. Yeah, good to see everyone. Let me pull on Dan as well.
Hey, what's up, guys?
Hey, Dan.
How you doing?
So everyone listening now, Dan is a dad. So he's Dan the dad.
That's true. As of 2 weeks ago, new dad.
That's still new dad, yes.
Yes.
Will you count like the moms like, oh yeah, my baby's like 36 months old? Or will you say 3 years?
I think he'll rank it by skills. Like now he's programming C++, now he's programming Python.
Yeah, right. Does he have control flow down yet? Does he know inheritance?
Is he going through Alchemy University already?
We're trying to get him there. He's still trying to understand the whole keyboard thing, and
yeah, his application's a little iffy.
I love it. So, agenda for today for everyone that is the first time that is sinking to this weekly content kickoff is showing what is the content of the next week about. So, what you're going to learn, what kind of value, what kind of skills you're going to acquire. And also, from my understanding, I think Dan as a demo for the project of the previous week. So,
It won't be a demo of the project, but it's going to be a demo of some stuff that is going to be relevant to what we went over week 5. So
okay. So
won't spoil the surprise.
I'm so curious. So we won't have project reviews this week because, of course, we had the holidays, and we will have Dan and his amazing skills showcasing what happened during week 5. So I will take a few seconds to send all the messages if you want to engage in random conversation. How's the life as a dad?
That's a good question. Yeah, it's interesting. I think it really does. Something that really occurred to me, I think, as like a new parent is like once you have a kid, it just like automatically kicks in that like your priorities just shift. And I just assumed other people were just really good at being parents, and they just automatically start to really care about their kids. But it's just something really innate that just happens to you. I feel like I don't know if anyone else is a parent or new parent feels the same way. Feels differently. Feel free to let us know in the comments.
How to show my comments in the live stream? You cannot. I'm sorry, but we can. Look at this. Boom. Everyone is shocked hearing that you became a dad. Look at that. No comments. It's like ignoring this fact completely. They're just like, kids are hat.
I sort of agree, but that's also because I don't have one. So
we were all a kid once. Maybe some of us still are. We know some of you are the coding prodigies out there deploying smart contracts with millions of dollars in them at 13 years old.
There are people that are like literally 13 years old and they are going through Alchemy University. Like we saw them writing entire threads about what they learned and the applications they've developed.
It's so cool. That was the thing that really got me into this space, is the fact that like just anyone could, build these really cool financial primitives, right? Like there's no gatekeeping in that regard. So it's quite wild.
All right. So I sent the messages all around. So as always, as every week, we're also running a very small giveaway, smaller than the one during the alpha, and the rules are always the same. So if you want to win some Alchemy swag, there is something special this week because something new has arrived. Just take a screenshot of the live session and post it on Twitter, tagging Alchemy Learn and any of the speakers today. So we have Codes MacB that is probably a trademark that is registered everywhere at this point. Dan, what's your name, your handle on Twitter?
Mine, Dan Nolan. It's kind of like
Dan Nolan.
Yeah, kind of like being John Malkovich. If you guys ever saw that one,
I love that movie. And post it on Twitter. And at the end of the live session, we will raffle the winners. By the way, do we want to get started with the content release and show off what is going on, or do you want to start with the week 5 first?
Yeah, let's do it. I'm happy to jump in. You want me to present?
Yep.
All right, let's do it. Ooh,
Let's
nope,
do it.
that's my
I'm gonna
camera.
leave the stage to you.
All right, cool. Let's see. Share screen. All right.
Let's see if everything works. Because StreamYard is kind of annoying sometimes. Yes.
Cool. Can we
You
see
got
it?
this.
Awesome.
You
Okay,
got
so
this.
maybe the first thing we could do is just take a quick look at what was last week, just so everyone can kind of remind themselves what we were working on. We did quite a few things last week. So if you guys are all the way caught up, you'll have done mappings, events, the escrow contract, reference types, and we had the decentralized escrow application. So what's really cool about this week is it really does make up like the core of Solidity contracts. Mappings and arrays and structs and events are going to be such core pieces of all of your smart contracts to this point where you can actually start to build projects, right? So the escrow is like the first project that we have you build. Hopefully you guys really enjoyed that one. Hopefully you're also starting to master the ability to be able to interact between different contracts, because that is such an important piece to being able to build good smart contracts, right? You want to be able to interact with the Uniswap contract. You want to be able to interact with the Aave contract, and understanding how smart contracts pass messages to each other to be able to interact is going to be so pivotal here, along with all these different data structures. So something I want to do to kind of demonstrate some of the things that we learned last week is take a look at an exercise. And I wonder if somebody could tell me what's wrong with some code I'm going to write. So what I'm going to do, is this okay, Vito? Can I jump right into the demo here? I think so. All right, let's do it. So what I'm going to do is I'm going to go ahead and just create a repository, and I'm going to call this, let's say, Dan's bug, right? And I wonder if anyone could tell me what the issue is going to be. I'm going to open up this new repository into Visual Studio Code, and we're going to take a look at what Dan's bug is going to be. So the first thing I'm going to do once I get into VS Code is I'm just going to create a package JSON where I can install all my dependencies. I'm going to install Hardhat here. So hopefully you guys have gotten pretty familiar with Hardhat at this point, where you are using it to build smart contracts, to deploy smart contracts, and to unit test smart contracts. That's going to make you a really, really strong Solidity developer. So getting familiar with this is going to be super, super important. Once you have Hardhat installed, you can run npx Hardhat, and this is going to allow you to create a new project. I'm going to create a JavaScript project, but you can create a TypeScript project if you want to. If you're familiar with TypeScript, we highly encourage it. A lot of the space is moving towards TypeScript, so it's really great to see that. What I'm going to do is I'm going to build a contract now, and Cody or Vito, if you guys see somebody telling me what the vulnerability to this smart contract is, feel free to shout it out or post it on the live stream. I would love to see somebody point it out. What I'm going to do is I'm going to create a license identifier. So I always misspell license, so I have to keep it right next to me to remember. I'll create MIT. This contract is going to be called a bank contract, and we're going to use Solidity 0.8.4, or really just anything above this. This is what we've been using throughout all the content, so I'm just going to keep 0.8.4 in here. So what I'm going to do is I'm going to create a contract called a bank. And so we learned about mappings last week, right? A mapping is going to be the most important data structure inside of Solidity. It's one that you're going to see time and time again. What mappings allow us to do is map a key to a value, right? And this is really, really important inside of Solidity, because very often what you're trying to do is just map somebody's balance, right? So this is the most common type of mapping you're going to see, mapping somebody's address to an unsigned integer, right? Because this can store balances. This could be a token, right? A token that is keeping track of everyone's balances. This could be a bank where you deposit Ether and then you could withdraw that Ether later. That's the goal of this one, is we're going to deposit some Ether and then be able to withdraw it later. So I'm going to call this my user balances, and I'm going to keep that private. And then what I'm going to do is I'm going to have a function called deposit. And this function is going to allow me to send some ether. It's going to be payable, which means that we can send some ether to this function. And when we do, we can respond to that occurrence, right? To having that ether being deposited into the bank. What we're going to do is we're going to increase our user balances for the person who sent in the ether by how much ether they sent in, right? So you guys should be familiar with this message global by now. The message stands for literally message, because when you send something to a smart contract in the EVM spec, it's called a message call, right? So a message call is sending some data to a smart contract. Inside of that message call, you're going to see some very familiar parameters. The parameters are going to be like value, and that's going to be how much ether you're sending through. There's also going to be the sender. That's whoever's sending, this particular message. You're also going to see gas, how much gas is being forwarded along, and then call data as well, right? And call data, at this point, you should be familiar with the fact that it's typically ABI encoded function signature and arguments to target a method on another smart contract, right? So this is going to be a message call. In this particular case, we're caring about the message sender, because whoever sent this message is trying to deposit some funds into our bank contract, and they're trying to send some value, which is going to be ether here, right? Cool. So that's a bit of review from message calls when we went over in week 4. And then what we're also going to do is we're going to create this withdraw function. So this is going to be the two functions of the bank. One is to deposit and one is to withdraw. Hopefully this is a better bank than FTX was, so we can always get our funds out later on. So we are going to go ahead and say, let's look up the user balance by going and taking a look at this user balances for the message sender. And what we're going to do is we're going to make sure, first of all, that the user balance is greater than 0. Otherwise, this user has no balance, right? And we're going to revert in that case. And then what we're going to do is we're going to go ahead and send them whatever they have, right? So let's go ahead and send that to them. What we've been teaching you guys to do since week 4 is to use the call syntax, right? This is the low-level syntax to actually initiate a message call with another account inside of the EVM. To do this, you could say message.sender.call, and then you could pass in your value and your gas parameters in here inside of this curly brace syntax here. So for the value, we're going to send them over the user balance. And then inside of the parentheses here, you can send over call data. In this case, I'm not trying to send over call data because I'm not trying to target a method on the message sender. If the message sender was a contract, then maybe I would want to send some call data over and maybe try to, target a function, send some parameters over as well. But in this case, I'm just trying to send some ether to the person. So I'm just going to say empty string, which is saying I'm not passing over any call data. Now, this is complaining right now because it wants us to take the low level or take back the success, whether or not this message call was successful, and actually require that. Solidity requires that we handle this success message or this success Boolean. If the message call was not successful, then what we want to do is we want to revert in that instance, right? So that's why we're doing that syntax right there. And finally, the last thing that we want to do is now that we've sent this ether over to the message sender on withdraw, the last thing that we want to do here is make sure that we zero out the balance, right? So we're going to say user balance. Did I call it user balances? Yeah, user balances message sender is going to be equal to 0. Cool. So we have our bank, right? You could deposit some funds into the bank, some ether into the bank, and then you could withdraw some ether out of the bank. And this kind of makes use of all the things that we learned last week and the week before, between mappings, between message calls, between reverts and requires. So at this point, it should look pretty familiar, right? Something we haven't gone over is why this bank right here is insecure. There's a vulnerability in this bank contract, and I wonder, can anyone see it? Has anyone called it out in the comments?
So we have 2 comments here. The first one, both actually are from Space Falcon. The first time he said vulnerability is underflow overflow.
That's an interesting one. So if this was Solidity 0.75, right? If this was, or sorry, below 0.8, I'm so used to 0.75 that I just say 0.75 by default. But if this was before 0.8, anything lower than 0.8, that would have been an issue. But with Solidity 0.8, they actually introduced reverts by default when you overflow and underflow values. So in this case right here, we wouldn't overflow user balances. And if we were subtracting user balances, we wouldn't underflow because it would revert by default. Like if I did something like, let's say user balance, message sender, minus equal user balance or some number here, potentially this could go below, this could underflow, right, which would flip over the bit range. And that's a really good thing to be concerned about. But in 0.8, they actually made it so if this goes below 0, it'll actually revert by default. So that's a really good point, but not something we have to worry about in this particular instance because of the Solidity version.
So also Space Falcon, after a little bit, proposed another kind of vulnerability that is re-entrancy, and also Amit mentioned re-entrancy.
Great. That's what it is. You guys figured it out. It's re-entrancy. Re-entrancy is going to be the issue here. Now, re-entrancy by itself is not necessarily a bug. The word re-entrancy, what does it mean? That's what we should go over first. So what does Space Falcon and Emit? I'm not sure who the other person was. What do they mean when they say re-entrancy? When they say re-entrancy, what's happening here is with Solidity, everything is single threaded. When you execute code inside of the EVM, it goes line by line by line. There's no concurrency inside of the EVM today. So what that means is line 16 executes, then line 18 executes, then line 20 executes. Now, the next line to execute after line 20 is not necessarily line 21 here. What actually potentially executes after line 20 right here is the smart contract message sender. Message sender could be two things, right? Message sender could be either an EOA, which is an externally owned account, right? And this is kind of what we were expecting here, right? Because somebody who's interacting with a bank, they probably are just an externally owned account, somebody with a private key, public key, who's just trying to send Ether to the bank. But they could also be a smart contract, right? If they're a smart contract, then they're deployed at some address somewhere. And when we say .call, even though we're sending in no call data, this does kick off some code on the smart contract. So what happens then, let's say we had a smart contract, and this is the depositor. This is a smart contract that is calling into our bank. If we had a smart contract that was calling into our bank, what would happen here is we would, let's say we had a function, and we'll call this, let's say, attempt. We'll just do attempt something fishy, right? Let's do a re-entrancy function, right? So if we knew the bank address, let's say address bank, we could take this address right here and we could cast it into a bank type, right? So this contract right here, the definition, we're going to use that to say that this address right here behaves like an uppercase bank, like an uppercase bank contract. By doing that, we can do something like this. We could say .deposit. Now, when we call deposit is going to allow us to send some Ether into the bank so that we actually start with a balance, right? That's what we want to do as the depositor, is we're going to want to start with some balance. So we're going to have to send over some Ether. So in order to do that, we first have to send some Ether into the depositor. So we need to make this payable. And what we'll do is we'll pay all of that forward into the bank. So we'll say the value here is going to be whatever Ether is sent to the depositor in this case, right? So we'll go ahead and do that deposit. We'll send over the message value. There's no arguments on deposit, so that's all we really need to do there. And then the next thing that we're going to do is we're going to do the re-entrancy. So right now we established a balance, right? This is establishing a balance on the bank for the depositor, right? So the depositor in this case is going to be the message sender. So the message sender is whoever most recently sent the message call, right? So in this case, it's going to be the depositor contract, and the depositor contract is going to have a balance stored in the user balances mapping here. So what we need to do now that we've established a balance on the bank, is we're going to go ahead and do the re-entrancy part, right? So what I'm going to do is I'm going to call bank.withdraw. Okay. So right now I haven't done anything malicious. If we were going to call bank.withdraw, the next line of code that's going to run is 16, then 18 is going to run, then line 23. Now what happens here when it says message.sender.call is it's actually doing a message call back to the depositor function. What's going to happen here is the depositor function has to have a place where it can receive Ether. Otherwise, this is going to revert. So for smart contracts, if you want to receive Ether, you do have to program with no call data. You do have to program a special type of function, which you guys should be familiar with at this point, called receive. And this function right here is going to be the default function that's kicked off when you receive Ether. This should be called contract here. Sorry, that's why it's complaining. Sorry if that confused you guys there. Should have named that contract. Receive right here, this is going to receive Ether. So right now, we could actually have this depositor work with the bank and everything would work okay, where we could deposit some balance and then we could withdraw it. And then we're going to receive Ether here in the receive function. This is where re-entrancy comes in. Line 23 right here. When we do line 23, this message.sender.call is actually going to kick off this function. So line 23 runs. The next line of code to run is not line 24, but line 32 down here. So this line now, we actually have the ability to do something interesting, which is we could re-enter the function. To re-enter the function, we can call message.sender. Now message.sender, this is a little bit confusing at this point, right? Because we're using message.sender so much. Keep in mind, message.sender is always going to be the last person to make the call, the last smart contract or the last EUA to make the call. In this case, the message.sender for the depositor is going to be the bank calling back into the depositor. So the message.sender here is actually the bank. So what we could do is we can call back into the message.sender and call call withdraw again. Okay, so what's the issue here? If we called withdraw again from inside of the receive function, we're going to go back up here to the withdraw function, and it's going to look up our user balance, and then it's going to go ahead and send us that user balance again before it sets our user balances to 0. So let's say that there were 2 balances inside of the bank. Dan has 10 inside of the bank. Dan has 10 Ether inside of the bank. Maybe Cody has 20 Ether. And Vito is a baller. He has 100 Ether. And then we have somebody else, the depositor, right? The depositor starts with, let's say, 30 Ether inside of the bank. Now, what the depositor could do is the depositor could call withdraw the first time to withdraw its 30 Ether. This right here is going to withdraw the 30 Ether for the depositor, right? Because what's going to happen is it's going to look up the user balance. The user balance for the depositor is going to be 30 Ether. And then it's going to go ahead and send that Ether over to the depositor. Now, like I said, the next line of code that runs after this one is actually going to be this receive function here, this bank.withdraw. When this happens, it's going to call back in and it's going to re-enter the withdraw function. And because these 2 lines of code haven't run yet, the user balance is still going to be 30 for the depositor, even though the depositor has already received their 30 Ether, right? Because this user balances mapping has not been updated yet. This is a classic re-entrancy bug. And what the depositor is going to be able to do here is the depositor is going to be able to steal everyone else's money. They're going to be able to steal Vito's money, Cody's money, Dan's money. And Vito is the most at risk here because he was a baller and put so much Ether into the bank here. This is classic re-entrancy. It's one of the first vulnerabilities that you learn about in Solidity. And we've talked about enough concepts to be able to actually start to talk about this vulnerability. Hopefully, most of these concepts are pretty familiar to you at this point. Cool. So there is one issue still with the depositor. The depositor is going to have a problem the way it's written right now, which is that it never exits, right? Eventually it's going to run out of gas. And when it does, the whole thing is going to revert and it's not going to receive any funds, because what's going to happen? It's an infinite loop. It's going to do the deposit. It's going to do the withdraw. The withdraw is going to come down here to call. Then it's going to go to receive. It's going to call withdraw. It's going to come back here to call, to receive, to withdraw. If you could see it, it's an infinite loop, right? There's no exit condition. So one thing we might want to do for the depositor, if we're the malicious person over here, is we might just want to have like a exploit Boolean. We could make this an unsigned integer if we want to exploit a couple times, or we could just make this a Boolean, and we could say, let's set the exploit to true by default. And we'll say if exploit is true, then go ahead and withdraw. Oop. I meant to put curly braces there. Right? If it's true, then go ahead and withdraw. And then we're going to set exploit to false so that next time we come through the receive function, it's not going to do it. So it's just going to try to withdraw twice. And that way it doesn't run out of gas. And that way it can actually successfully take some of the other bank members' money. Cool. Sweet. So what I want to do is I want to actually deploy this to show you guys, how this would work. Does anyone have any questions before we give that a shot? I wonder if we could take some questions from community. Do you guys see anything over there?
No, we have side explanation about re-entrancy and how re-entrancy guard works. But other than that, it looks really, really clear.
Whoa, cool. Okay, sweet. So somebody's already explaining re-entrancy guard, which is one of the ways that we could have prevented this from happening. So really cool. It sounds like you guys already know quite a bit about this concept. That's great to hear, because everyone's like being able to catch on here. Okay, sweet. So then maybe what we'll do is we'll just go ahead and deploy this, right? So there's a couple different ways we could deploy this. Maybe to keep it simple, we'll just deploy this on my local blockchain. You could totally do this on Gurley. So I recommend that you guys try this out sometime, do some re-entrancy, see how this works. Let's just do this on my local network and we can test it out like that. So what I'll do is I'm just going to create inside of Dan's bug, I'm going to create a npx hard hat node. This is going to run a local blockchain for me, and it's going to give me a bunch of private keys that are unlocked by default. And then I'm going to connect to this thing to deploy these smart contracts, right? So what I'm going to do is for my networks, I am going to make my default network localhost. And what this is going to do is Hard Hat knows this to be a special keyword. It knows to go looking for a blockchain that is running on your local host 8545. So it's actually going to go find this blockchain. And when we deploy the contract, it's going to go ahead and deploy it here using the first account in this accounts array that we see here. So what we will do is we'll go ahead and deploy this. Let's go ahead and do that. In scripts, you're going to see a deploy function. We can get rid of a lot of this stuff. We really just need to... For the deployment, we're going to need to deploy the bank. That's going to be the first thing. Let's just make sure that we can get the bank working first, and then we'll deploy the depositor. The bank takes no arguments, right? It doesn't have a constructor, so we can just pass in, we could just invoke the deploy function here without having to pass in any arguments. And so we'll go ahead and run that, and then we'll say bank.deployed, and then we'll say bank was deployed to, and we'll get the address. Bank.address. All right, awesome. So let's do that. That's going to be our first script. So our first script, we're going to go ahead and say npx hard hat run script/deploy. By default, it should run on my local host now because of the network config that I did there, right? So, whoop, looks like I messed something up. Networks default URL. Actually, I guess maybe I mistyped that. Let me look up the hard hat documentation. The default may be something else. Let's see. Oh, it's called default network. Yikes. And it's actually outside of the network's config. Sorry about that, guys. I often forget how to configure this thing here. It's called default network. It's outside of networks config, and that should give us what we need. And now it's saying deploy doesn't exist. We just need to put the .js there. And this will go ahead and deploy it. So now our bank is deployed to this address right here, 0xF5B. And you can see over here that we have this contract address, 0xF5B, inside of our blockchain right here, right? Okay, cool. So let's write a couple other scripts while we're at it. So another script that we want to write is we're going to do like a deposit, right? So with our deposit, what we're going to do is we're going to take some account and we're going to deposit some funds with it. So let's say this is Vito. Vito is going to deposit 100 Ether because we have so much Ether inside of all of our different private keys here, right? So we're going to give Vito, do you have a favorite number? Wait, Ether's
13.
13.
1-3. Yeah.
Okay. So we'll do ethers.provider get signer. Vito is going to be signer 13, although that's technically signer 14 because it's 0 indexed. So I don't know if that bothers you or not. We'll just put the number 13 in there. So this will be Vito. Vito is going to he's going to send some Ether to the bank. So the bank is going to be stored here at this address. If we want to be able to interact with this bank, we just have to say get contract at the bank and pass in the bank address there. This is going to return us a contract instance, an Ether's contract instance that's pointing at this bank right here. And then what we could do with Vito, oh man, this is really bothering me that everything is not tabbed over. You get really OCD with this stuff. Okay. With this bank now, what we could do is we can go ahead and deposit. So Vito is going to be our depositor. We're going to say Vito bank.connect as Vito. And we want to call, what do we want to call? We want to call the function called deposit. And we want to be able to pass in our arguments here. So we're going to say Vito.connect. We're going to pass in, we're going to say, bank.connect, yeah, deposit, and pass in some value here. And this value is going to be 1,000 Ether. So we do need to parse the Ether in order to do this. We need to do, let's do something like this. We're going to have to say hre.ethers.parse Ether. There's two utilities that people get confused about quite often is parse Ether and format Ether. Parse Ether means it's taking it from the human and parsing it for the machine. So it's taking something that is, you know, makes more sense to us and makes it easier for the machine to interpret it. So in this case, it's taking the number 100 and it's interpreting it and turning it into 100 E18 because we want to turn it into way. There's also format Ether, which does the opposite. It's taking it from the machine and turning it into something that's more human readable, right? So if you want a way to remember that, the difference between parse Ether and format Ether, somebody once said this in our bootcamp. They said format is for Matt. So you can think of a friend named Matt, or maybe your name is Matt, and it's for you. So it's being taken from the machine to show it to you. Whereas parse Ether is for the machine. We're taking it from us and parsing it for the machine. So you're going to have to do this very often where you're going to have to parse it because you want to do it 100 E18 in this case. So we're going to go ahead and pass that. Oh, yes.
We have an amazing question from Stalin Macias that is saying, how would you explain the difference between get contract at and get contract factory?
Yeah, great question. So let me actually just pull over here. I'm going to pull over documentation real quick. So one really important thing to note about these methods is they come from a plugin on Hardhat called Hardhat Ethers. So if you're looking for the documentation of these two methods, you're going to find it on Hardhat. And if you search, so you can see what I did there a second ago. Let me actually zoom out so you guys can see. They have a search bar up here for Hardhat. That's actually really, really helpful. Search for the plugin Hardhat Ethers, and this is going to show you the documentation for those two methods that was just asked about. One method is called get contract at, and one method is called get contract factory. These are not methods that are built into Ethers by default. They are methods that help configure Ethers with your Hardhat environment. So what it's going to do for get contract factory is you can plug in the name of a contract and it's going to go look up the ABI and the bytecode from your artifacts folder. So let's take a look at this real quick. So if I was on deploy, we have a method called get contract factory. What this is going to do is it's going to take this bank string and it's going to go into my artifacts folder under contracts, and it's going to find this bank.json, and it's going to find two really important pieces of information in here. The ABI is going to help you interact with the contract, right? It's going to tell you, here's all the methods that this contract will respond to, which is going to help you format call data to interact with that contract, right? And then there's the bytecode, which is what you're going to need to use to deploy this contract. So the big difference between get contract factory and get contract at is get contract factory needs that bytecode because you are going to deploy this contract. So contract factory is going to deploy a contract. That's where you get the name contract factory from, because it's a factory. It creates a bunch of contracts, right? So when you want to create a new contract, you want to get contract factory, which is going to go get the ABI and the bytecode, as opposed to get contract at, you only want to go get the ABI because you're going to be interacting with a method, or you're going to be interacting with a contract that already exists. So in this case, we're interacting with this bank, which I'm just realizing there's two bank variables here. I should name that bank address. You're going to be interacting with a contract that already exists. So we don't need a contract factory. We need a contract pointing at an already existing contract that can interface with it through the ABI. Great question. Cool.
Amazing. Thank you, Dan.
Yeah. Awesome questions, guys. Sweet. So we will go ahead and deposit with Vito. And if that's successful, then we should have 100 Ether in the bank. And yeah, we should be good to go. So let's do that. Let's do a npx hard hat run script / deposit.js. And we'll see if that works. It says parse ether is not a function. That's correct. It's hre.ethers.utils.parse ether. See, everybody makes mistakes with this stuff. All right, cool. Wait. Bank deployed. I didn't change my console.log message. I should just say Vito is a baller, right? If it was successful. One thing that we might have wanted to do here is wait for the transaction to actually get included in the block, but we can go look over at our blockchain and see that the deposit was successful. So Vito deposited his 100 Ether into the bank. Maybe he should have waited for a couple other people to put in the bank first because, you know, he's the first user, he's the early adopter, and as we can see, there's a re-entrancy bug here, right? So Vito might not be in for such a good time now. Cool. So what we're going to do is, one thing that we might want to just do real quick is another function, another script that's going to be called get balance. And the reason why I want to do this one is just to prove to you guys that the re-entrancy worked. So this bank address right here, if we want to see how much Ether is in the bank address, we could just basically copy over all the stuff we had before. We had the bank address. We're going to get the contract at the bank address. And then we're going to say bank dot, we're actually going to say hre.ethers.provider.get balance at the bank address. And this is going to return us an amount in Ether. So what is the balance here? And now, again, I told you guys, we're going to have to use the other one. We used parse Ether, but now we're going to have to go the other way. We're going to have to do a, let me get the balance. So let's do a ethers.utils.format Ether, because we're going to take a balance, which is going to be a big number of way, and we want to turn it into Ether. So it's format, it's for the user. So we're trying to show it to us. So we're going to take a look at that balance in a human readable way. And hopefully that'll be 100 Ether. So let's go ahead and test that out. We're going to say, I'm going to clear this out. And I'm going to say npx hard hat run get balance scripts / get balance.js. And hopefully 100 Ether. All right, so there's Vito's 100 Ether, perfectly secure. He has nothing to worry about. He could sleep at night, but maybe not too tightly because there's a re-entrancy bug. Let's go ahead and exploit it. So that's going to be the next piece right here. We're going to go ahead and exploit this. I'm going to call this script exploit.js. And with the exploit.js, we're going to do something similar to deploy. So I'm just going to pull over that code, but we're going to deploy the depositor in this case. And we're going to do a couple things, right? So we're going to take the depositor, we're going to deploy it. And once we have the depositor address, we're going to interact with the depositor. So we'll wait for it to be deployed. And then what we're going to do is we're going to say depositor dot, what did we call the method on the depositor that's going to start the exploit? I forget. We called it re-entrancy. All right. So we're going to start the exploit with this depositor.reentrancy. In order to start this exploit, we do need to give a balance to our depositor, right? Because the depositor, in order to be even successful in this, they do have to have a balance to start out with, right? Because if we call withdraw without a balance, this is going to fail. And even if it didn't fail, it would just be sending us 0 ether at a time, right? The balance, the initial balance, is what's going to actually allow us to withdraw multiples, which is going to allow us to start to drain Vito's balance over here. So that's what we're going to do, is we're going to go ahead and exploit it. We're going to say, let's say the value is going to be, again, we need one of those utils, right? So the value is going to be hre.ethers.utils.parseether. Let's drain Vito's ether 25 at a time, right? So if we're successful at the end of this, the bank should only have 75 ether inside of it, right? Because Vito started out with 100. We're going to withdraw 25 twice. So the depositor contract should end up with 50 inside of it, and then the bank will only end up with 75, and Vito won't be able to pull out his whole 100 anymore. So let's go ahead and try this reentrancy. We're going to pass that in there. So when we call reentrancy on the depositor, what is it going to do? It's going to say bank.deposit. It's going to pass through that message value on the message call. It's going to deposit 25 into the bank. Then it's going to call withdraw, which at this point it's withdrawing 25 ether for the depositor. It's going to come in here. It's going to look at my balance. It's going to be 25. It's going to say, okay, I'm going to send you over 25, right? And then it's going to come down here. Exploit is going to be set to true initially. So it's going to come in here, set exploit to false. So next time we should exit. Then it's going to go ahead and withdraw again, which is going to give us another 25. So hopefully you guys can see what's going on there. So let's go ahead and deploy our depositor. The last thing we do need to do, though, is pass in the bank address here so that the depositor knows what bank to target, right? Because they're going to be deployed at 2 different addresses here. Even though these contracts are in the same file, we are deploying them to 2 different addresses on the blockchain. That's kind of a new thing too to a lot of people. That's kind of surprising, is you can keep 2 contracts in the same file and deploy them to 2 separate addresses. Sometimes it's a little hard to keep track of that in Solidity, to remember, okay, this contract is deployed somewhere else and needs to interact through an interface or through call when you're encoding your own call data, something like that. So let's go ahead and do the exploit. With reentrancy, we do have to pass in 1 argument here. That's going to be the bank address. So let's grab the bank address here. We're going to plug that in. And it's going to be our first argument to reentrancy. And this thing right here, by the way, you guys might be kind of confused about why I have like the curly braces syntax here. This right here, the bank address, is going to be the 1 argument for the reentrancy method. So if we take a look at the bank.sol here, reentrancy has 1 argument, right? It's a bank. So when I pass in this bank address, that's the 1 argument. This right here, the last argument, is an optional argument that you can use. In Ethers.js, this is called the transaction overrides. What you could do here is you can override the values that Ethers is going to plug in that exist on the transaction. On the transaction, you have things like gas, you have value, you have the signature, you have call data, things like that. You can override some of those in this particular spot, the value being one of those that you might want to override. Cool. So that is going to do it. And if this works properly, then the reentrancy should occur and we should drain 25 of Vito's funds here. So let's go ahead and try it. We're going to say npx hardhat run script/exploit.js. And okay, so we got no console.log, but if it was successful, then when we run get balance, there should be 75, right? There it is. And if we run exploit again, we could drain even more of Vito's funds, right? And Vito's not withdrawing here, but all of his money is going to 0. Vito just got rug pulled on his own stream. Sorry, Vito. So there we go. We did the exploit. We pulled out Vito's funds 25 at a time. I do have a question for you guys, which I want to see how well everyone was following along. What do you think inside of the mapping for the user balances for Vito's address? What do you think the unsigned integer is for Vito's address inside of the bank right now? Does anyone have a guess if we were to look that up?
Also, why it's me always getting bragged?
Sorry, Vito.
Vito, please check your real balance. I did it for the whole entirety of this session. At a certain point, I wasn't sure anymore if it was using like the testnet or it was the actual like my account. And I was looking at it, be like, "Yeah, good job, wow, Dan, you're very good."
Vito's like, "Wait a minute, this was all on the main net."
Wait, that was all real?
Oh no!
Amazing. So anyway, question that Dan asked, super important. What is the unsigned integer?
Yeah, what do you guys think for Vito's address here? Do we have a comment on that one? I don't know if I can see the comments. I have no idea how to see them.
Oh, I will display them and read to you.
Okay.
No worries. That's why I opted.
Oh, I see where you guys are. Cool. Oh no.
There was a lot of us. After the funds were drained, after the funds were drained, Vito balance would be 100, but the contract won't have the funds.
Exactly. Yeah, who said that?
It's Stalin.
Stalin.
The guy that asked before the question about get contract at and get contract factory.
I don't know how to spell, but
Stalin. Yeah.
Way to go. So exactly right. The idea behind it is that for the user balances, interestingly enough, in this mapping, Vito's address is actually still going to map to 100 or really 100 E18 because we have all those decimals, right? Vito's address is still going to map to that. So he still has like a claim, so to speak, on his user balance, but the actual funds stored in the bank, the balance of the address in the bank stored in the world state tree of Ethereum is going to be 0. So even though Vito still has this claim to his 100 Ether, it just doesn't exist on the bank anymore. Awesome. So that means you guys are paying great attention to that. Very cool. So I know a couple people mentioned some ways that we could have prevented this on the bank, things that we could have done to make sure that this didn't happen. There's really 2 big things, maybe 3 I'll go for here. The 3 big ways that you could have made sure that this wouldn't have failed is 1, checks effects interactions. I'll talk about what that is in a moment, but you should always use this phrase to remind yourself how to write Solidity code. We'll talk about what that means in a moment. 2, there is something called a re-entrancy guard, which is great. You could use this whenever you're concerned about re-entrancy and you want to just take it off of your concerns, your list of concerns, right? And then 3 is going to be we could change the gas amount. I don't love this one, but I'll talk about what that is. So we could basically make it so no re-entrancy. There's a couple actual ways that you can make it so that you won't allow re-entrancy. The re-entrancy guard is probably going to be the most explicit and best way to do that, but we could talk about what I mean by the gas amount here. So checks into effects interactions is going to be the most important one. The way to solve this is actually really, really simple. Guys, it's really just, I got to remember how to do my keys. It's really just moving the user balances up here. If we had, instead of keeping it down here, we move this up here to this line right here, this would have solved the issue. Something like this would have stopped the DAO hack from happening. So if people know what the DAO hack is, this was like the biggest and earliest vulnerability that happened inside of Ethereum. There was something like 20% of all Ether was locked up in a smart contract when Solidity was still very early and Ethereum was a very early project. And there was a re-entrancy bug like this, more complicated because the DAO was a very complex piece of smart contract code, but it had this type of vulnerability. And moving one line of code like this would have solved the issue. Why does this solve the issue? It solves the issue because if we look up the user balance right here, so actually, I would actually have to move this one down here. So we'd want to look up the balance after we zero it out, right? And then we'd probably want to do something like that. So maybe we could do something like this. Actually, I think it was okay. Sorry, I'm a little tired, but let's just do something like this, right? I'll put this 0 here. So we're going to, oh yeah, you know what? I do need that. Okay, sorry guys. So the user balance, okay, so let's say that in this case, it was the depositor, and the depositor had 25 Ether inside of it. The first time that we go to look up their balance, it's going to be 25 Ether, and it's going to pass this check. Now what it's going to do is it's going to set their balance to 0, and then it's going to go ahead and send them over to the 25 Ether. If they tried to exploit and they tried to withdraw again, when they call withdraw and they re-enter the function, what's going to happen this time is it's going to look up the user balances, which is going to be set to 0. Because we moved this line of code up, this user balances is modified by the second time we come into the re-entrancy. When it's down here, that line of code doesn't get called until after all the re-entrancy occurs. But when it's up here, we're modifying that storage variable for the next time the re-entrancy comes around. So where this term checks effects interactions comes from is up top here, you have your checks, right? The first thing you're doing is you're doing checks to make sure that the balances is proper. You're checking what's typically referred to as like invariants, or things that you want to always make sure are true about your smart contract. You want to check those types of things, like make sure that this person actually does have a balance. So you want to do that first. The next thing that you want to do after that is you're going to want to do your effects. So this is going to be your effect. You're actually going to make your modification to modify something on the smart contract before you do your interactions, right? This is going to be your interactions down here, where you're going to call out to other smart contract. Because when you do your interactions, you're allowing somebody else to take control of the execution flow. And when you do that, they could do whatever they want, right? So you want to make sure that when you give up execution control to another smart contract, that your smart contract is in a good state, right? Because if you don't, then if your smart contract is in bad state, then it could potentially be exploited, right? You want to make sure that you have all your ducks in a row before you give up execution flow to some other smart contract. Cool. So that's checks, effects, interactions. The other two really come in with something called the re-entrancy guard and changing the gas amount. The gas amount is a little bit simpler, so I'll talk about that first. So something that you could have also done here is right here, you could say gas 0. So you can actually say that I want to make this message call, but I don't want to give the person who's receiving this Ether any gas to be able to respond to this method. I don't recommend doing this because you do want to allow smart contracts to run code. Like, the correct solution to this isn't let's make sure that smart contracts can't run code. The correct solution is let's make sure that smart contracts can't exploit vulnerabilities in our smart contract or can't re-enter if we just don't want them to re-enter. In this case, by doing gas 0, you're just not even allowing whoever's receiving this message call to run any code. That's not the proper solution here, right? Because then you're going to make it so things like Gnosis multisig, you guys are going to learn what multisigs are this week. If you don't already know what they are already, you're going to make things like Gnosis multisig unable to account for this new Ether that's being sent over to it, right? Because if you say gas is 0, it can't run any code because any code is going to take some gas. So this is not the correct solution. It is technically a solution if you want to make it so that smart contracts can't run any code, and maybe all you're trying to do is send to an externally owned account. In that case, then gas 0 could potentially prevent this, but again, I wouldn't recommend it. So not recommended. You could also do something where you like detect if the message sender is a smart contract. There's some caveats and weird stuff with that as well, which we won't go into. All of that is bad practice. So this is really bad practice. So the two good practices that you really want to do here is checks, effects, interactions, and something called a re-entrancy guard. For re-entrancy guard, what you can do is you can create something like a modifier, and we could call it like a re-entrancy guard. What you could do in the re-entrancy guard, so for modifiers, remember the underscore is a thing that runs the function. So we could say re-entrancy guard here. And for the re-entrancy guard, what you could do is you could require that some Boolean variant is true. And then what we'll do is we'll have a re-entrant variable. And what we'll do is we'll set this to true initially. But once you enter the function, we're going to send this to false, right? So if it came back around the next time, this will be false and it will fail. And then we could set this back to true at the end for the re-entrancy guard. So what essentially happened with this is withdraw, the first line of code that's going to run for withdraw is going to be this line right here, require re-entrant. Re-entrant is going to be true by default. And then what it's going to do is it's going to set re-entrant to false, then run your code, which is going to be this code right here. Then if this function ever gets re-entered into at some other point in the transaction execution lifecycle, we're going to come back up here and re-entrant is going to be false because of this line of code right here. That's a little bit confusing, I'm sure, for a lot of people, like coming into Solidity and still being very early on. The thing that's like helpful to remember here is that re-entrant is a storage variable. And for storage variables, you're modifying like something that's persistent, right? So even though like we may be re-entering at some much later point in the transaction cycle, so like maybe it's like after a couple calls and then you re-enter back in, this storage variable is still going to be set to false. So it's not going to allow it to re-enter later on. So this is another really good practice. I'd recommend doing both, right? If you're concerned about re-entrancy, set a re-entrancy guard. It's always good to be careful. Even if it costs a little extra gas, that's okay. I mean, it's better that your users are safe if you're really concerned about re-entrancy. And then always, always, always do the checks effects interactions pattern. There's no reason not to do it. It's literally just moving. Oops, sorry, I keep doing that. It's literally just moving your line of code up here to make sure that you put these in the correct sequence. So make sure you always do that. That's really, really important. Cool. All right, that's my demo. Do we have any questions from the crowd there?
That was amazing.
Sweet.
I'm looking. So we have sparse questions about different things that you said. Like Stalin here is asking, how does it work? Call the function. Let me show you. Can you see the screen?
Let's see.
How does it work? Call the function isn't supposed to forward all the remaining gas to the called contract.
Yeah, great question. So call by default, when you don't pass in the gas right here, by default, it's going to pass all remaining gas along. So like the user at the very beginning of when they sign the transaction, what actually happens when a user signs a transaction is typically the whatever you're using to sign that transaction, let's say it's MetaMask, it's going to call out to your node provider and it's going to say estimate gas. It's going to do this method called ETH estimate gas. And ETH estimate gas is going to run your code. It's going to run the smart contract. It's going to run the transaction, and it's going to come up with a number for what it thinks the amount of gas that you should use. So what's going to actually happen here on line 44 is, let's say like, 100,000 of the gas was used and you only have this much left. It's going to take that number and basically pass that along to the caller here. So it's actually going to send all of that gas over by default. So unless you specify a gas amount, it'll send everything over. So the caller will be able to spend all the gas. Now, because it simulates the transaction, if there's a re-entrancy or something like that, it's going to take that into account with the original estimate gas. So yeah, in that case, an exploiter would easily be able to come up with the correct estimate for actually being able to have enough gas to be able to run the exploit over and over again.
All right, and now we have another question from Gonzalo that is asking, I think it's more of a clarification. What about concurrent withdrawals? The variable would be false and then the second call couldn't get in.
Yeah, so there is no concurrency in the EVM currently. There's been talks about adding like the ability to run two transactions at the same time if it's known that you're not modifying the same storage variables. People have been talking about creating clients that do that. I don't think it's in any of the Ethereum clients today, but currently there's no concurrency at all. So it's very much like JavaScript, where when you are running a transaction, you are running it and you have the entire EVM to yourself. So If you get the first slot in a block and there's like 100 transactions after you, your transaction runs entirely in its entirety before the next transaction does. And then that one runs in its entirety before the next one. Same thing with when you call out to a contract during a transaction's life cycle, it's going to run the code line by line by line. So this message.call right here is not going to create like a new process. It's not going to create a new thread. It's just going to run the next line of code after this one inside of the message sender.
And then you have a ton of fans that are like, yeah, that was an amazing demo. My brain is satisfied. Thank you, Dan. You're amazing. No, that was really amazing. Thank you so much, Dan. I learned a lot as well. And I'm sure that all the people that are listening today learned a lot as
Awesome.
well. We also have Al that joined us.
Oh, Al joined?
Yeah.
Welcome, Al.
He's not on the stage, but is in the viewers.
Cool.
Done amazing by GDG. Alrighty, so we are already at the end of the hour. Do we want to touch rapidly on the content for the next week?
Yeah, I think so. So, I mentioned to you guys, you're going to learn multi-sigs. So multi-sigs are super, super important. And I think they're going to become even more important. We can talk about that as well, but I think they're going to become even more important as time goes on for just like the Web3 space as a whole, because just the ability to be able to sign off with multiple keys gives you things like being able to recover your funds in the case that you lose one private key, right? Or if you have a group of people that want to sign off on a transaction and you want to have like 3 of 5 of friends being able to sign off on a transaction, like an organization, multi-sigs are super, super important. You guys are going to learn about that. And then finally, you're going to learn about inheritance, which is going to lead into ERC20s and NFTs. Because with inheritance, what we can do is we can inherit from smart contracts that are programmed by people that are way smarter than us, like some really, really great auditors and awesome teams in the space, like Open Zeppelin. Open Zeppelin does a phenomenal job of putting out ERC20, NFTs, all the different standards that are available in the ecosystem, and they audit those smart contracts so that way you can actually inherit from these smart contracts and build on top of them. So you're going to learn about inheritance first, and then you'll see how important that is for creating your own ERC20s and NFTs. So super, super excited to jump into ERC20s and NFTs. I'm sure everyone else is as well. I know that's going to be really, really important for the road to Web3 stuff. If you guys haven't started that already, make sure to do that after this bootcamp because you'll be totally ready to go for that.
100%. And we also have a couple of like big alpha releases that are coming soon about things that are happening at Alchemy University. Dan is connecting. What is Vito talking about? Do I know about that? Yes, you know about that. I'm sure you know about that. 100%. So no, that was amazing. Thank you so much, Dan. I'm super excited for next week. Everyone is super excited for next week. We published the syllabus for the next week content on Twitter and social medias, and everyone went completely banana, thinking of the things they will learn. Can I start the bootcamp on this track if I haven't done the first 5 modules?
Yeah, go for it. You can hop right in wherever you want to hop in.
Is that suggested, though?
No, not necessarily. I mean, so you'd be surprised that some of the stuff that we do teach in the earlier weeks that really comes into play in the later weeks. Even if you're someone like Stalin, I noticed you know a lot about the space already. You may find that there's some stuff that we talk about that's really important to week 6 and 7. So I'd recommend taking a look, going through, perusing, and seeing what's like helpful. And then maybe starting week 6.
So yeah, and then we have other comments. Anyway, I think we can also wrap up the giveaway now that we have gone through the demo and the weekly content release. So as always, the winners of the giveaway will be announced on Discord for the super simple reason that is way easier for us to keep track of who are the actual winners, because Discord allows you to connect your profiles. So go on Discord, we will announce the winners in the next 20 minutes. And then GDG will take care of everything else. GDG is also in our chat. I will quote one of his messages. It disappeared probably at a certain point. Here we go. So GDG, the guy with that profile image, will take care of everything. Thank you so much for tuning in. Dan, any closing remarks? Cody, do you want to jump on stage to say bye to everyone? Cody's
Yeah, I
like,
want, I
no.
want to see Cody. Yeah. Hey, Cody.
You're muted.
I'm muted.
Yeah.
Now we can say goodbye. Now that
Now we
Cody's
can say goodbye. Yeah. Yeah, it was great. It's probably like the 50 to 100th time I've probably seen a version of that sort of presentation, and it's always like something new as we go through the different versions of Solidity. I don't necessarily touch Solidity much anymore, but I think I put in the chat earlier, like, who remembers 0.4, and someone said nobody, and like that's like where I learned how to really deal with Solidity and smart contracts, and it's just so cool, like seeing all the new little tools that's in 0.8, and like the way they've kind of just made it a lot better to develop in Ethereum. It's just really cool to see. So every time I see these presentations, it's super interesting. I learned something new.
We got a request to see your biceps, Cody. I don't know.
Can you show us your bicep?
It's from Al.
Yes, it is, of course. Who's the
Al.
only person that can write that?
Al, after work.
Not
We'll
safe
take
for
that
work.
offline.
Offline. I'll fly out to
Thanks a
area.
lot, Vito and Dan and Cody. You guys are awesome. Okay, folks, thank you so much. As always, once again, if you want to keep track of all the events that we're having in the community, I know there are a lot. Today, we had the Developers Guild sync. We had the Technical Writers Guild sync. On Wednesdays, we have town halls. On Monday, there are live sessions. Go on Discord and check on the left-hand side, the events section, and you'll find all the links, all the times, all the dates there. Just save the date, set the reminder, and Discord will send you a notification. For today, I will thank Dan. That was really amazing. I learned a lot. Thank you so much. And people were completely crazy about it. Everyone loved it. Hi, Hal. Hal is super excited as well. He loved it as well. Thank you, Cody, for bringing order and law to our streams every time. And
Is that how you do a heart? How do you do that? That's right. How do people do that?
This way.
I see. Yeah, I don't know if anyone does it this way. Oh, yeah, there we go. I'm freaking old. Sorry.
There's a peace, love, and Web3 reference in week 6 content. So
Is there?
Yeah, it's in there. So
Did we add it?
You guys will have to find that Easter egg. Peace,
okay,
love,
let's do this. The first person that finds the Easter egg will also win some swag.
Oh, there you go. Find the peace, love, and Web3.
Easter egg hunt.
Tweet us. Easter egg hunt.
Amazing, folks. Thank you so much, everyone. Have a great weekend ahead. And of course, peace, love, and Web3.
Bye, everyone.
Later, everybody.
See you.